I work for Metabolic. Metabolic is a engineering and consulting firm specialized in circular economy. And I want to tell you a little bit about our way of working and how it actually translates to economic value and job creation. Um, at Metabolic, we feel that cities are a very important leverage points for creating a more circular and more sustainable economy. Cities actually only occupy around 3% of the Earth's surface, but when you look at the waste that is produced there, the emissions that are tied to it, they're not just agglomerations of people, they're also agglomerations of resource flow. And so it's very important to see if we can manage these flows in a better way by designing and developing our cities sustainably. That's the big picture. What I want to talk about specifically today is why tracking material flows and tracking resource flows is key in tracking value and also um, uh, um, being able to see where you can add new types of sustainable and circular jobs in a city or in an economic system. Um, in Metabolic, we produce a lot of these diagrams. They're called the Sankey diagram, actually after a British captain, I believe, who made these types of schedules for steam engines. Um, and what you see here in this example, for example, you see all the material flows going through the American city of Charlotte in North Carolina. So on the left side, you see resource flows coming in. There's an oh, on the left side, you see resource flows coming in. There's a need of materials from households, commercial activities, the construction sector. And all of these ultimately end up in waste. And here you see what type of waste you have in the system in Charlotte and where it ends up also in terms of recycling, landfill, composting. So at a glance, you can really see that Charlotte's waste system, in fact, is not circular at all. Only 11% of the solids waste are actually recycled or composted, and the rest ends up in landfill. If you would do this for a Dutch city, it would be burned rather than landfilled, but still very suboptimal. So you see these pictures also visualize the need for a more circular development of cities. And in fact, a lot of valuable materials are lost here in this system. You can see that also by visualizing the same material flows in a different way. Mass is not just value, so if you look at not just the mass of the materials, which is the size of the bubble, but also the value of them, you can see that some quite small material flows actually have the biggest potential for economic gains. Like, for example, metals over here. They have a very small percentage of the volume, but a lot of the value in this system is actually in that material flow. So with these two different types of perspectives, both mass and value, we already try to scope out what is happening in this waste system and where can we intervene to retain the value rather than to lose it. For the city of Charlotte, without going into the details of the whole research, there's a 60-page report you can read online. It turned out that, for example, just from the plastics that are landfilled, you could actually get 35 millions of revenues if you would properly recycle them and turn them into new products. And you could create over 1,000 jobs. So this shows that while we start really from a material perspective, you actually end up with information that allows you to take action on the economic side of things. And I think that's quite interesting. I'm going to quickly walk through 3 types of examples at different scales of this same way of thinking. So the first one is supply chains. Of course, the most obvious place to look for economic value and job potential would be the supply chain of, for example, a company. I have a Dutch drinking water company, Vitens, as an example here. The graph is also in Dutch, you don't need to read it, but we did the same trick. We looked at their water production facility in the north of the Netherlands, and we outlined all the materials going in and out of that system. And from it we could see that in this case, actually, also they have a commercial interest to do so, of course. They've closed the resource loop to quite a large extent. So they're already using calcium in, for example, concrete and glass production. They're taking the iron out of the water to help in waste processing processes, for example. They're actually actively producing humic acids, which you can use as a soil fertilizer. So you can really see that they're quite advanced already. But yeah. By taking a second look, we also could find a lot of additional options for valorization in the same system. So we could also tie these material flows to business cases around circular inks, natural antibiotics, for example, both from the humic acids. And there were also applications in the region for calcium to turn it into building materials together with hemp, and to use it to improve saline agriculture, which is a particular issue in that part of the Netherlands. So here, tracking the material flows has really helped us to look for new types of business. And we can do the same thing with material stocks. For example, the urban mine, the material stocks that are in the built environment. For Amsterdam, I've done a research to actually track what is being released in terms of demolition waste every year. And a first estimation showed that it's between 600 and 700 million euros of value that is largely being lost and ending up as road fill in this sector. So that's a really great way to also trigger commercial interest in these types of resource flows. It becomes even more interesting when you can spatially pinpoint where those materials are being released. So this is an example also from Amsterdam, where for a housing developer, we tracked their assets and we showed where they have a surplus of materials coming because of renovation or demolition, for example the blue areas, or where they would have a deficit because they're actually building more and using more materials than they can regain from their own resources and assets. So this is a really interesting way to also trigger action at a project level and to find matches between donor buildings and buildings that require additional materials, preferably from a circular source. Because that's happening all around the Netherlands, there's also a whole industry that is now rising. So for example, there's an initiative by the Urban Mining Collective, which is a whole group of commercial companies that actually have made it their core business model to fully mine all the resources that they can out of the built environment when they become available, and sell them again for no more than the price of primary materials. So they also have a guarantee that you'll never pay more money for something circular and sustainable than for the new stuff. Final example, because I also got to move on, I think, is looking at food waste. So quite exciting, together with the TU Delft and a large consortium of partners in the Horizon 2020 project, we were able to track all the organic flows, all the waste flows for food in the Amsterdam metropolitan area. And this is a dynamic model. So before, where in my urban mining model, let's say the building blocks of the model were static, they were buildings, and you have to couple them to activities in terms of demolition. These are coupled to employees of a certain type of company, and the release of waste flows or the inputs required are predicted on the basis of that. The interesting thing is, and this is just a small example, you can take subsections of this model and activate them according to a certain business case. For example, making beer from residual bread and also producing yeast for that, and then creating a circular system for beer brewing. You can have it go, you can take parts of the model and only take those economic activities that are actually interesting in terms of an input or output for this business case, and see where those are. So you can actually start connecting not just the resource flows in terms of an idea, but also the companies behind them, and try to actively match them in the same way that we tried it before with the buildings. Now you can say you should talk to your neighbor because you have a bakery, but he actually requires your waste products to get started with yeast production or with beer. And you can actively couple these companies, which is much more specific than you would normally see with the first graphic that I showed, which was just a snapshot of the whole area. I think what I showed was a very fun and sort of cuddly example of this, but ultimately green chemistry, for example, is a really big rising industry in the Netherlands. This is an example for the harbor of Rotterdam. They use waste flows to create platform chemicals, to create bioplastics, for example, among other things. And if they can have these types of systems also for the resource flows that they need for these types of productions. You can scale them accordingly, and you can design on the basis what's actually available in the city. So to close off, I think creating value in jobs really starts with tracking material flows and the circular potential that they represent. If you really know what's going to be released where, you can also build a business on it. So you need to get this information out before you can start scaling up and making a serious effort with the economic part of the circular economy. Thank you.